I'll give charge 2q, 4q. Let me give a charge and the separation between them be d, and this is 2d. I'm going to close the switch S1, S2 simultaneously. What charge has flown through the switches? So there's a plate X, Y, and Z. The switches S1 and S2 are closed simultaneously. Find the charge flown through the switches. Net charge. Find the net charge flown through the switches. First electrostatic induction should occur. I count electrostatic induction 7q, 8q. This will be 4q. Q minus q. This will be plus 3q minus 3q. This will be 4q. Okay, all of you? The distribution of charges. Okay, now we are going to close both the switches simultaneously. Here, I think one more case is there. If S2 and S3 are closed simultaneously, I'll come back. Let me wind up one more case is there, no? Switch S2, S3. There's one more last case, very important. There's also. Again, why to take one more problem? We can save time. S1 is open. I'm going to close these two. I think these distances are of no use. Anyway, let it be. Now look at now. Both these switches I'm going to close simultaneously. What will be the charges? What was the charge of plate? Plate Z. What was the charge of plate Z? I think you are able to see completely. Okay, I'm putting boundaries. They're not related. Huh? Yeah, now look at this one. What is the potential of Y and Z? Will be equal, no? Because both are earthed. Vy equal to 0, Vz equals 0. Agree this? Vy and Vz, both are equal to 0. Then if potential difference 0, then what should be the electric field? Should be 0. If electric field is 0, no charge should reside here. So finally, what do we get? The charge of plate X is how much? 5q. The 5q will come here. A very, very, very fundamental thing, helps us a lot in numericals. I'll not show any charge here. Any reason? Vy, very, very important. What is Vyz? If Vy, Vz equals 0, Vyz will be 0. If Vyz is 0 means potential difference 0 means the distance is non-zero here. How much it is? 2d. Then potential difference 0, distance is non-zero, then electric field must be 0. If electric field 0, here the electric field will contribute these charges only. Go back. We have done so many problems. The field 0 means there should not be any charge here. So no charge will come here. Then the no charge should reside here. So this 5q, this 3q will come inside, will become 5q. It's induced charge minus 5q. How much of charge will flow here? What was the charge here? Minus q. Now how much it is? Minus 5q. How much of charge will flow here? I'll put green color so they'll be easier. Minus 4q. Then what was the charge of this plate? It was 2q, no? Charge of this plate was 2q. So how much it is? It is 0. So how much of charge will flow here? No, 2q. Agreed here? No, in this case. Always you have to show charge flow from the body to the earth, not from earth to the body. Actually, positive charge will flow here. Actually, some students will say, why can't you write plus 4q? So what was the charge of this system was minus q, no? Now how much it is finally? Minus 5q. Then how much of charge should leave? Minus 4q or plus 4q? I'm not seeing any objections. Why? Please do think. Minus q charge is there. Minus 5q means what charge will leave? Plus 4q charge should leave, no? Minus q now will become minus 5q. So 4q charge should leave this one. 4q plus 2q, 6q. You look at here now, when both the switches are closed, then also the net charge flown. Of course, 4q plus 2q. 4q will pass through this, 2q will pass through this. If you close any switch also, the charge flown was 6q only. Able to understand? Now, what is the method? Once again, I'll put it here. When you earth two plates, these are the adjacent plates, no? The potential of that is 0. Vy equal to Vz. Then Vyz is 0. Vyz 0, then electric field must be 0. If electric field is 0, then no charge should exist here. Anyway, no charge will exist here. Then all this 3q charge will come here, 5q. 5q minus 5q. What all that induced charge? Let it be that one. So the net charge flown through the switch S2 is 4q. 2q from S3. Net charge 6q. Okay, this is about the two switches. Huh? Either you close any one switch or two switches, this will be the charge. No, sir, I'll close switch S1 also. Then what will the charge of that 5q also will flow to the earth? No, here, let's come to the how we can manage this problem. We'll see that. So what is both S1, S2 are closed. Switches S1, S2 are closed simultaneously. Now we have to work out what actually happened. So shall we use just now what I discussed? I think these things I'll erase. The switch is earthed, closed, closed here. What is the potential of plate X and Z? Should be equal, no? Vx should be equal to Vz. Then what charges are there? We don't know here, but let's begin the problem in a different way. Definitely, I'm very sure no charge should exist on these faces. This is a practically proven thing. So here, no charge will exist on these plates when any one plate is earthed. Okay, fine. And the charge of plate Y should be converted to 2q charge there. So shall we put this Q and Q? Anybody objections? Then other student will say, sir, why you are writing Q? Why don't you write 3q and q by 2? Because he is also right. Other student will say that, sir, why 3q by 2? Better write q by 3, 2q by 3. Tell me who is right. So any charges? No. Practically, you go and check the potential difference. Take help of potential difference. Vy, Vx equal to Vz. This is what happens. Any reason for that? Because both are earthed. And if you earth it, potential of that should be 0. So therefore, what is the primary condition? Vyx must be equal to Vyz. Because y is a common, no? What is Vyx? The potential difference between plate Y and X should be equal to potential between plate Y and Z. So keeping that in mind, I don't know what charges it can be. So therefore, what I'll write it, let me write Q1 minus Q1. I'll write it small letter because the induced charge, no? Minus Q1. Q2 minus Q2. I don't know. Later on, I'll solve it. If I get Q2 negative, I'll interchange sign. I'm not sure that sign also, but altogether Q1 plus Q2 should be how much? Because this is not earthed. Q1 plus Q2 should be equal to 2Q. Conservation of charge principle. Let me write all. Plate Y, charge of plate is conserved. So therefore, how much it was? Initial charge 2Q, final is Q1 plus Q2, equation 1. Then plates which are earthed, potential of that should be 0. Vx equal to Vz equal 0. So therefore, what we can write it as Vx, Vy x should be equal to Vyz. What is Vyx? The electric field here E1, the electric field here will be E2. Because I'm assuming potential of plate while non-zero, potential of plate X and Z as they are earthed will be 0. What is Vyx? Should be equal to E1 into D. What is Vyz? E2 into 2D. No. What is E1? Okay, now you know electric field how to calculate. Q1 by there are so many things are there. What we have learned, we should apply here. Just now, previous class. Yeah, this E1 depends only on these facing charges, no? So still, if you're getting confusion, so you can take help of this idea. Tell me like here, the field at this point depends on what? Only these two. What about, sir, what about this? These charges will not, S will contribute. But you see like this phase and this phase. The resultant of these two at this point will be 0, no? That's why only due to this. Why Q1 by A? Charge density is how much? Q1 by A. And each face of a conducting sheet will behave like a non-conducting sheet. That's why 2. Solving this. See, what all we are studying, no, just we should apply this one in order. Q1 by D equal to Q2 by 2D, or say this Q1 equal to 2Q2. So Q1, Q2 we know, so solving these two, 2Q is equal to Q1 equal to 2Q2 plus Q2. So how much Q2 equal to 2Q by 3. How much Q1? Q by 3. So these are the final charges. How much of charge flown through the switch X and Y can we calculate? How much of charge here? Q by 3 charge will flow here. Either Q by 3 or any other charge. Anybody answers? Total charge. First, 5Q charge. Okay, let me show that here. Some other color. Yeah, we'll take this one. 5Q charge. Afterwards, Q1 charge. Q2 by 3. Similarly, what was the charge of this plate was Q, no? So first Q charge. Next Q2. Q2 is how much? 2Q by 3. Add up both. What was the charge? 5Q plus Q by 3. $16Q by 3 will flow here. How much of charge here? 5Q by 3 will flow here. Okay. So now, sir, why can't we just directly tell why we should do all this? if you, instead of earthing these two plates, if you earth these two plates, very simple. If you earth Y and Z, okay, no charge will reside. Just know what we had done earlier problem. Quite simple. If you earth these two plates, then potential of Y and Z should be 0. So therefore, Vyx must be equal to Vyz. So from that is what I'm going to predict, because these charges I don't know. So therefore, I'll find out by this method. Q1 is 4Q by 3. Huh? I'll check the data. I'll check the data. Q1 is how much? Oh, yeah, right. This will be 4Q. Huh? Q1 is 4Q by 3 means Q2 is correct, no? Okay, 2Q by 3. Okay, fine, yeah. A net charge flown through the switch S1, 5Q plus 4Q by 3. Net charge flown through the switch S2. Q plus Q2 or 5Q by 3. So shall we add up those data? Net charge five Q, so 15, 19Q by 3. Switch S2 will be 5Q by 3. Always you have to indicate charge flown from the body to the earth. Convention. Whether it is a positive or negative charge, whatever be that. What charge flown from the body to the earth, that should be taken.